Hello everyone, I am Mohammad Adnan Faisal Hussain from Group 1 of A2. Our project is Wheelchair Navigation System based on voice for physically challenged people. Here you can see our project outline. So why do we need a voice-controlled wheelchair? Traditional wheelchairs are slow, unable to change directions quickly, and require significant human labor to move. They are especially difficult for people with disabilities to use. Our proposed voice-controlled wheelchair solves these problems by moving at higher speeds with better navigation systems, and it operates only on human voice without the need for any physical labor. Here is a summary of our process. First, we perform speech recognition on the input voice command and convert it to text. We then transfer the text from our mobile device to the STM32 microcontroller via the Bluetooth module. The microcontroller interprets the command and sends it to the motor driver, which then controls the speed of the motors connected to the wheels. There are three main components. First, we have an L298 motor driver. It has two enable pins used to control the speed of the motors. In1 to In4 pins are used to control motor speed direction. Next, we have our STM32 32-bit blue pill microcontroller. STM32 receives UART serial data from the Bluetooth module using an interrupt-driven reception method. Finally, we have our 8C05 Bluetooth module. We use the BT voice control for Arduino app to perform speech-to-text recognition.
Assalamu alaikum. Now I will explain how we programmed our microcontroller unit using STM32Cube IDE. We used this platform to generate the hex file for simulation in Proteus 8.6. Here we can see the pin configuration. We are using pin 9 and 10 as UART 1 pin for serial communication with a Bluetooth module. The baud rate is set to 9600 bits per second. As you can see, pin PB2 to PB7 are used as output pins that will serve as the control pins of the motor driver. Now, in clock configuration, the operating frequency was set to 8 MHz and the rest of the parameters are set to default. Now, as we jump to the source code, we can see the auto-generated clock configuration function, our UART1 and GPIO pins initialization function. We defined a variable RX buffer to act as the buffer for incoming data, and a string variable voice to hold the voice string. We created few functions for motor control. In the main function, we are invoking the UART receive ID function to receive serial UART data in interrupt mode. After each byte is received, a callback function is called, and a received character is concatenated to the voice string. In the while loop, we are searching the hash symbol that marks the end of a string. The voice string is compared with predefined commands. If a match is found, the intended operation is performed, and the voice string is reset to 0 to restart the procedure.
So this is the simulation part of our project. Here we've used an STM32 IC. Inside the IC properties for the simulation, we've used the hex file that we generated from the STM32Cube IDE as the program file. For crystal frequency, we've set it to be 8 MHz, which is something that we used in the STM32Cube IDE as well. Along with this IC, we're also using two Bluetooth modules. One is the transmitter and the other is the receiver. Along with the IC and the Bluetooth modules, we're also using a motor driver and two motors to complete our simulation setup. Now, if we move on to the operation part of our simulation, we'll be typing the commands into the virtual terminal. The transmitter side will not be visible, but the receiver side will be visible. So first we'll be typing in the command forward, and we can see that both the motors are starting to rotate clockwards. And now if we type in our another command backward, both the motors are turning counterclockwise in the same direction. Now if we type in the command left, then to turn left, at first the motors will be turning in opposite directions, and then they'll start turning in the same direction, because after taking the left turn, the device will be starting to move forward. Now if we type our command right here, we can see again the motors are turning in the opposite direction in the beginning, then eventually they start to rotate in the same direction and the vehicle goes forward. And finally, if we type in the command stop, then the whole device turns off and thus executes the whole operation, and that's the end of our simulation project.
Hello, I'm Roll61, and now I'll be talking about the hardware implementation of our project. Here you can see a list of hardware materials that were used for our project. Here is the circuit diagram for our project. STM32 microcontroller is the main programming unit of our whole project. HC05 Bluetooth module is being used for wireless communication. The commands are received by the Bluetooth module, which are sent to the microcontroller. After that, according to the instructions of the microcontroller, the L298N motor driver operates the two motors connected to it. We are using two 300 RPM DC motors and they have rubber wheels attached to them. Finally, we have designed a wheelchair prototype using PVC boards and there is a caster ball in the center to balance all the equipment on it. The serial port of STM32 is interfaced with a computer by using a USB to TTL converter with the following connection. We are using Arduino IDE to program the microcontroller. Now we will have a look on our source program. So initially we are declaring all the ports that were used in hardware connection. After that, some functions are specified according to all the possible commands by a user. In the loop function, we are checking for inputs given by the user. The input is taken character by character and the hash symbol indicates the end of an input string. After that, the input string is stored in the string named voice. Our wheelchair can perform 6 automated tasks and so we match the input string with these 6 commands. If there is a match, then the wheelchair executes the command accordingly with the help of our specified functions. These functions mainly control the wheel movements according to the instructions that are given. For our project, we have also designed a PCB layout. Here you can see our PCB layout design file. It consists of 4 layers, which are illustrated with 4 different colors. PCB is designed with open source EasyEDA tool. Here you can see our final PCB output, and here is the 3D rendering of our PCB.
Forward. Right. Backward. Turn. Backward. Left. Stop.
So first of all, we could implement the voice commands that we used here in Bengali language so that it becomes accessible and usable for everyone. In the future, we can build the voice dataset that we used here on our own rather than using the Google API, and we could also incorporate deep learning technique here for better performance. We could also add an extra feature to recognize the unique voice of the owner so that the command reception system is very trusted and secure. To conclude, we intend to include all of our features in a real-life wheelchair. We want to optimize our system further for mass-scale production. We are very thankful to our course instructors, Dr. Sajid sir and Onyx sir, for letting us work with this interesting project. Thank you everyone for giving us a patient hearing.